This is Algebra 2 with trig, 14.1 and 14.2. We are going to graph sine and cosine functions. We will also look at the reflection of sine and cosine functions. What I'd like to talk about first is how these graphs are made. Here's your parent function. The sine graph, you can look here at a basic unit circle where we talk about the coordinates as 1, 0, 0, 1, -1, 0, 0, -1. Those are the main coordinates that we need to know for graphing the sine and cosine graphs. At 0 degrees, 0 is straight to the right. If we're going to talk about sine, that's the y value. At 0 degrees, we're at 0. At 90 degrees, or pi over 2, we're at 1. So if you're looking here at the unit circle, you'll see that the values are matching up right with what the unit circle would be. At pi, the y value is 0. At 3 pi over 2, we're at -1, and at 2 pi, we're at 0. So trying to remember what's happening in the table, it is all part of the unit circle. It's all back to related to that. So we're at 1, or we're actually 0, then 1, then 0, then -1, and back to 0 again. Cosine is going to do the same idea. At 0 degrees, we're at 1. So we're off the x-axis. Here's your origin. So we're up at 1. Then we're at 0, then -1, then 0, then +1. And it just repeats that pattern again and again. When we look at these, we can notice that the domain for these are your x values, and those are your angles. We typically write these in radians. Your domain of the function is all real numbers. So you can plug in any angle, a positive angle, a negative angle, a really large, a really small, and you'll have values for all of those. The range, if you notice, as we have talked about before, it has a high point of 1, it has a low point of -1. So your y values are greater than and equal to -1, but less than or equal to +1. And we've recognized that on the unit circle that all the coordinates for sine and cosine are between 1 and -1. The amplitude. The amplitude is the value in the graph that goes up and down from this, what we could call a midline. So here's your amplitude. This line that the graph is going above and below, that could be called a midline. We'll refer to that a few times today, but the main part when that starts to change is when we translate the sine and cosine graphs. Our amplitude is half the distance, or half the difference of the maximum and the minimum number. So we're going to take half of 1 minus -1. Well, 1 minus a negative is actually 2. So half of 2 is just 1. So our amplitude, as you can see here, goes from 0 up to 1. Each function is periodic, which means the graph has a repeating pattern. And you can see that in the graphs that are drawn here, that it reaches the maximum every 2 pi, keeps repeating itself as it goes through the whole unit circle. The shortest repeating portion of the graph is called a period. I'm sorry, of the graph, that period's later, of the graph is a cycle. Here is a cycle. For the cosine graph, we typically highlight from 0 up to 2 pi. Notice that cosine is 1. It's all the x values on the unit circle. But when you compare that to what the cosine graph is going to look like, the cosine graph is down here, and that started at 1, but the sine graph started at 0. So the two graphs do look a little bit different from each other, but from a distance, they look very similar also. They're just actually translated sideways a little bit. They're slid, and then you start to repeat it. They have the same maximum height and minimum. The amplitudes are the same. The midlines are the same. The horizontal length of each cycle is called a period. So our horizontal, so we're going from 0, then we have pi over 2, pi, 3 pi over 2, and 2 pi. So the period is 2 pi. That's the angle at which it takes it to get all the way through its curve, its cycle. So we'll take a look here. What happens when an A value is negative? Your A value is in front of the sign. We all know what happens in this situation. We've had negative values in front of our functions all year. So we should have an idea. So when we talk with sine, we talked about how it was 0, 1. It was 1 at pi over 2. Then it was back to 0 at pi. And then it was negative 1 at 3 pi over 2. And it was back to 0 at 2 pi. So there is your graph of y equals sine of x. And with a negative value in front of the sign, you know that we're going to turn all of our y values, multiply all those y values by -1. So if we're working with our function y equals negative sine, at 0, we're still going to get 0. At pi over 2, we're going to come down here to -1. We multiply it by a -1. And then 0. And then our reflected graph goes up to 1 and then back to 0. So notice what happens for y equals negative sine of x. It gets reflected over the y equals x-axis. It's y equals 0, which is the x-axis. You should be able to predict what's going to happen here with the cosine graph. If the cosine graph is typically at 1, then 0, then -1, then 0, then 1. Okay, that's your y equals cosine of x. When we do our negative a value, we are going to reflect this over the x-axis. Notice that when I graph these and I draw the curves, that they are actually curves and not V shapes. So try not to make it go up and be really sharp, but try to make that continuous curve the best you can. Y equals negative cosine of x. So notice that these are reflections of the original graph. So as usual, I like to graph the parent function, and then we reflect it. If it has a negative, then we could stretch it. We would stretch it if the A value is something different than 1. And that's called your amplitude. We have a change in amplitude when that A value is something different than 1. An amplitude other than 1 causes a vertical stretch or shrink of the graph. It affects the maximum and minimum. The amplitude itself is always a positive value. Remember, looking at the note that we had on the other page, the amplitude was here. The amplitude was the distance from this midline to the maximum. Yeah. Reflection. Now, the part that gets these all really confusing is this change in period. When the graph is actually going to go through its full cycle in a shorter amount of time. Right? It just goes faster. Faster heartbeat is going to go through it quicker over the same amount of time. So what we're looking here is the B helps us determine the change in the period. So look at where the B goes. The B is in front of the X for both sine and cosine. To find the period, change the X value in the table by multiplying it by the reciprocal of B. And that'll give us our new values. And since a normal period is 2 pi, we can also find the period by taking 2 pi divided by B. That will give us what the period amount is. We have our increments, and that is going to be pi over 2 divided by B. Pi over 2 divided by B. You could also call that pi over 2 times 1 over B. 2 different ways you could think about that. All depending on how your values come out. You know that when you have a denominator, you multiply by the reciprocal to simplify those fractions. So the steps for graphing our trigonometric functions. In the form of y equals a sine of bx, okay, for us to graph those, we're going to get the initial y values from our table for our sine graphs, and we're going to put those into our table. We're going to get the initial x values from the table of our radians for each of the quadrantal angles. We're going to find the y values in the table by multiplying the values by a. We're going to look at the stretch after we do our parent function. And we're going to find the x values by working with the reciprocal of b. So let's work through a couple of these. So here, The main thing we really want you to be able to do is recognize what the equation looks like. What does this equation, how does it affect the graph? So we have this 3 that's in front of the cosine. So a 3 in front of the cosine is going to stretch the graph. This is a cosine graph. So typically we start with 0, then pi over 2, then pi, 3 pi over 2, then 2 pi. That is 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2 as you're working through that. Your parent function for cosine, remember, think of your unit circle. If you don't remember your numbers, think about your unit circle. At 0 degrees, your cosine value is 1. At 90 degrees, it's 0, then -1, then 0, then 1. We can graph this out. I'm going to count by 2s in this situation, just because that's still going to fit on a graph. So our cosine graph starts at 1, then we go to 0, then to -1, then to 0, and to +1. Now that looks like a V shape. We don't want to draw it like a V shape. We want to try to curve those corners so it looks more appropriately drawn. And that would be y equals the cosine of x. Now we're going to look at the amplitude, the 3. How does that affect our graph? That's going to push us up to not even 2, but all the way up to 3. -2 and -3. So that stretches out our graph. Now we're going to start at +3, go to 0, then to -3, go to 0, and to +3. You multiply your y values all by the 3. Y equals 3 cosine of x. We see that the amplitude, the distance that there is from our midline all the way to the top, is 3 different units. So the amplitude is 3. The period at which it covers, period is always 2 pi divided by b. So our b value in this case is the value that's in front of the x. There is no value, so that's just a 1. So it's 2 pi divided by 1. So the period is 2 pi. We could see that when we were graphing it, that this first location here would be pi over 2. Then we would have pi and 3 pi over 2 and 2 pi. You want to try to write in what they're called increments. What steps are we doing as we're graphing these out? Our midline, what is the graph kind of curving around here? It's curving around y equals 0, which is our x-axis. All of these are going to have a midline of 0 until we translate the graphs on Wednesday. So for letter B, think about how this graph is going to change. Look at your equation. Look at the -5. Look at the function. How are those things going to change what the original graph is going to look like? The original graph, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. We always go by the angles that make up the unit circle at the axes. Those are called quadrantal angles. For sine, those are the y values. The sine goes 0, 1, 0, -1, 0. Every sine graph, the parent function starts out just like that. So we're going to start out. I'm going to need to go by ones in this case because we're going to stretch this to 5. So I don't have room to count by twos. So we count by ones on the way up and I count by ones on the way down. So we're at 0, up to 1, back to 0, to -1, back to 0. So that's our graph y equals sine of x. Now, just like we have done before, we work with the RST graphs. Next, we're going to graph the negative function of this. So we're going to reflect it. So that means we're going to take all the y values and multiply them by a -1. So that gives us our y equals negative sine of x. Then we can use our -5. The S part of RST is the stretch. So we're going to stretch this by a 5. So instead of going down just 1, we're going to go down 5. We come back to the 0, so that doesn't change. 5 times 0 is 0. We're up here at 1, so we times that by 5. We go all the way up to 5 and back to 0. Remember, when you graph these, try to make them rounded corners. Y equals -5 sine of x. Our increments in there. Our increments were pi over 2, pi, 3 pi over 2, and 2 pi. Each one of those lines was one of the angles that we had talked about in our table. Our first one was 0, and then it was pi over 2, pi, 3 pi over 2, 2 pi. The amplitude. The amplitude is the absolute value of -5. So it's 5. That's your amplitude. The period. The period is 2 pi divided by b. Well, our b is still 1 so far. So our period, it took all the way out to 2 pi for this to calculate. And the midline is still 0. Any questions about that? So we graphed sine and cosine when you had A values. Now we're going to look at what happens when you have B values. Your B value is going to change the increments. It's going to affect what the period of the graph is. We know that the period equals 2 pi divided by b. That's the period. The period in this case is 3. Or the b in this case is 3. So the period is 2 pi divided by 3. Now to figure out your increment, what am I doing wrong here? Is there an A in there? I think so. Anyway, our increments is pi over 2 divided by b. Those are our increments. So our b value is a 3. So we have pi over 2 divided by 3. So we're going to call that pi over 2 times 1/3. So our increments go by pi over 6. So over here we have 0. Then we go to 1 over 6, 2 over 6, 3 over 6, and 4 over 6. 4 pi over 6. Well, what is 4 pi over 6? That is your 2 pi over 3. That was the period that we said it should take. It should finish in that same amount of time. So that was a good way to test it. This is going to be pi over 2. This is going to be pi over 3. We're just counting by 30 degrees at a time. Pi over 6. We got the pi over 6 by doing our increments. Our y value. This is a sine graph. So our y values are 0, 1, 0, -1, and 0. So if you want to get your increments put in here ahead of time, pi over 6, pi over 3, pi over 2, and 2 pi over 3. All right, that came right off the table. Looks like we could have room to count by 2s in this case. So we'll be at 0, going up to 1 at pi over 6, then back to 0 at pi over 3, down to -1, and back to 0. So we curve right around there for our sine of x. Actually, it's not x, it is 3x. We don't graph the original parent function in this case because it changes up our scales. It's really cool to see it drawn in there. What you should recognize is that the normal graph doesn't reach 1 until you get all the way to pi over 2. And it doesn't reach 0 until you come back down to pi. It's a much longer graph. But because of the 3 that we had here in the equation, that has shrunk us up. That has made the graph much quicker. We don't see it as much quicker in here, except if you're looking here at the angle values. Now we're going 30, 60, 90, 120 instead of 90, 180, 270, 360. It's going through the graph much quicker. We don't see it so much except for the numbers around it. The amplitude is a 3. So now our graph is going to go all the way up to 3 and all the way down to -3. You want to try to make those rounded. So we get y equals sine. Oh, I'm sorry. That was a total fail. Was there a stretch in this graph? No, there was no stretch in this graph. I'm just making it. And here I knew it. I was ready to write it. And I'm looking at my equation. Wait, there's no number in front. There was no number in front. Sorry about that. That graph was our only graph, right? So our amplitude was 1. The period, we calculated the period up top. as 2 pi over 3. And the midline was still y equals 0. Let's take a look at this one. Think about our steps here. What are we going to have? This one has an A value that's negative. So you know there's a reflection. This has a B value that's pi. So this is going to have a shrink, a horizontal shrink. So we're first going to start out with calculating the period. The period is 2 pi divided by B. So your B value is pi. So we're going to be, oh, you can see any of that. All right. So you get 2 pi divided by B. We're dividing by the pi. So that's giving us a value of 2. Now, what are we going to do with this 2? What's our next step? Okay, what we've talked about before, the increments. There's no A in increments. I was making that up. So for our increments, we typically our increments are pi over 2, right? So we're going to divide that pi over 2 by our B value, and that our B value now is pi. So we have pi over 2 divided by pi, which is pi over 2 times 1 over pi. So we're going by 1/2, going by a half. So we're 0, 1/2, 2/2, which is 1, 3/2, and then 4/2, which is 2. And didn't we say the period was 2? Didn't we say the whole graph was going to go through 2? So that's why that last box is going to be the period. It will always be the period. This is a cosine graph. Cosine starts at 1, then to 0, then to -1, then to 0, then back to 1. So I'm going to go by 3 lines this time so we can really see it curving through here. So we start at 1. This first increment is a half, so you might write a half in there, and then 1, and then 3 over 2, and then 2. Sometimes it's better to put your dots first and then curve your lines through. Okay, so there are your values for the cosine of pi x. What's our next step we need to do? You've got to be involved with this. We're going to reflect it over the x-axis. So we're going to go down to -1, we're going to go up to +1 and back to -1. So that's y equals negative cosine of pi x. So we know our amplitude is 1. It's the value in front. It's the absolute value of the A. The period we've already calculated to be 2. And the midline for these is still the x-axis. We did not change by a translation. All right. The rest of these are just kind of working through the same thing. So this gets a little tricky because we're talking about 1/4. All right, so thinking about how your graph is going to be made. All right, so we probably want to go up 4 lines to make our 1 and down 4 lines to make our -1, just so we can clearly figure out what 1/4 is. It'll help us. The next part that we had been working on is figuring out what the period was. The period was 2 pi divided by b. Well, that's 2 pi divided by 2 pi. So that's going to cross out completely. So now your period is 1. So the increments is 2 pi divided by 2 divided by, I'm sorry, I think I said that wrong. Pi divided by 2 divided by the b value, which is 2 pi. And we would need to write that as 1/2 pi. So that is 1/4. Now let's think about what 1/4 does to our table. 0, we have 1/4. Then we get 2/4, which you could call as 1/2. Then you get 3/4. Then you get 4/4, which we could call as 1. And we've talked about how the last box is going to be the period. That's how it takes to go all the way through the graph. And then it would repeat from there. This is a sine graph. So the sine graph would typically start out at 0 and then go to 1 and then to 0 and then -1 and back to 0. So we know that our increments are going to be 1/4, then 1/2, then 3/4, then 1. That's how your x's are changing. So we're going to start out, this is a sine graph, so we're at 0, up to 1, to 0, and back. Y equals sine of 2 pi x. Okay, now this is really tight. So what's our next step we need to do? Make some choices. What do you see that we need to do next? Looking at your equation, do you have any negatives? Do you have an a value? Okay, we're going to shrink it. We're going to shrink this by multiplying everything by 1/4. So that makes the graph a lot tighter. So y equals 1/4 sine of 2 pi x. So the amplitude is 1/4. The period we've already calculated to be 1, and we have y equals 0. We'll start out our next one here, number 3b, by finding the period first. The period is always 2 pi divided by b. Well, in this case, that's 2 pi divided by 1/4. Well, you take your 2 pi and you times it by the reciprocal. That's going to make 8 pi. This is the first one that we've seen actually stretch out longer. So now we're going to be at 0. Oh, we got to figure out our increments. I don't know what to put in my table. How do I know what goes in my table? I need to do increments. And that's at pi over 2, or it's really, if you don't like that one, this could be much easier actually. Period divided by 4. Maybe you like that better. I definitely do. 8 pi divided by 4 equals 2 pi. So we're going to be 2 pi, then 4 pi, then 6 pi, then it's your period. So you might like your increments to be period divided by 4. You know that the sine graph typically goes with 1, 0, -1, 0, and 1. If we're going to stretch this by 3, maybe I can get away with going a scale by 2s. So then this would be 2 and -2 and 3 and -3. So I have to plan ahead a little bit. So my cosine graph typically goes from 1, then we're going to say 2 pi, 4 pi, 6 pi, and 8 pi. This is a cosine graph, so it makes it more like a U shape. So y equals cosine of 1/4 x. Okay, so we look back at our graph and we notice that there's a negative, so we're going to reflect this. So that's y equals negative cosine of 1/4 x. And then we can stretch that out to 3. So we go 3 down, we go 3 up, and we go 3 down. So y equals -3 cosine of 1/4 x. So our amplitude is 3, our period we counted as 8 pi, and our midline is y equals 0. Going down to our next one. We see that we have stretch because 5/2 is bigger than 1. And we have a b value of pi. So our period is 2 pi divided by b. So we have 2. Our increment, remember we've talked about doing it period divided by 4. So your period is 2 divided by 4. So we're going to go by halves. So that means we're going to do 0. We're going to do 1/2. We're going to do 2 halves. We're going to do 3 halves. And we're going to do 4 halves. And that 2 is the same thing as our period, like it'll do every time. A cosine graph always starts at 1. We're going to do our parent graph and we'll stretch it. So this is stretching up to 2.5. So we have to have room for about 3. So 1, 2, 3. We could go, it looks like, by every other one here. And our cosine graph would start at 0. And here we have a half. We have 1. We have 3 halves. We have 2. It's often easier to write those in before you start to do the rest of your graphing. So that is not just cosine of x, that actually included the pi for the b value. Okay. Now we'll be able to stretch it. So we'll go up to 2.5. So this is 2.5. So we're going to go up to 10. 2.5, down to 2.5, up to 2.5. So this is y equals 5 halves cosine pi x. So your amplitude in this case is 5 halves. The period we calculated was 2, and of course, our midline is still here at the x-axis, 0. Last one. This has a reflection. This has a stretch vertically, and this has a shrink horizontally. So we'll take our period, which is 2 pi divided by b. So pi, our increment, is going to be the period divided by 4. So pi divided by 4. So what that means, we're going to go to 0 pi divided by 4, 2 pi divided by 4, which reduces to pi over 2, 3 pi over 4, and 4 pi over 4, which is just pi. This is a sine graph, so we're at 0, 1, 0, -1, and 0. We're going to be stretching by 2 all the way up to 4, so I don't really have room to double up. So this has got to be 1, 2, 3, 4. So our original graph is going to be 0, 1. This would be pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4 and 4 pi over 4. So that is our y equals sine of 2x. Then we're going to reflect it. So it's going to come down and up. So that's y equals negative sine of 2x. And then we're going to stretch it. So it's going to go 4 times that direction. So we get y equals -4 sine of 2x. Our amplitude was 4. It's the absolute value of it. The period was pi that we calculated earlier, and the midline is y equals 0. That helps.